With 3.3, we're going to be looking at the graph of ax plus by equals c. So how do you graph an equation that looks like this on a coordinate grid? We did it a little bit in the last section where we kept solving for y. If you remember, we got y by itself, and then we're able to graph it as if it was in slope-intercept form. But now we're going to just figure out, well, how can we just deal with this? Maybe use like a shortcut so that way we can graph it right away in this form. Remember, this is called standard form. So the standard form of a line, of an equation of a line, as we already said, is ax plus by equals c. And to be a little bit more specific with it, if you remember, a, b, and c are real numbers. And then x and y are your variables. So what we're going to do is we're going to mess with this equation here, ax plus by equals c, and see what we can get out here for the slope, y-intercept, and x-intercept. We'll be able to take care of the slope and the y-intercept by just using this equation here. We're going to start with this, ax plus by equals c. And we're going to be able to get the slope and the y-intercept by solving this equation with no numbers for y. So going back to actually chapter 1 where we solved equations with just letters in it, variables, we're going to solve this for y. So how do we do that? Like we normally do, we're going to move this ax over to the other side by subtracting it. Minus ax on both sides. So on this side it cancels. Over here we have just by. And we have c minus ax. I'm going to put the ax part first, the minus ax, because we're used to seeing the x part first. And then the other number, the c, just add that on at the end. They don't go together. They're not like terms. And the last thing we have to do is divide both sides by b. We have multiplication here, so we have to divide. What happens? They cancel out. Now we have y by itself. And we got to simplify this a little bit. B is going to go into the negative a, and it's going to go into the c. So how do we write that? We just split it into two different fractions. So we're going to have negative a over b with our x there beside it, plus c divided by b. So why do we even do that? Changing this standard form to this new form, well, what is this called? This is called the slope-intercept form. So now, just relating a, b, and c, we can figure out, well, what's the slope and what's the y-intercept? So if we look at up here, what's the slope? The slope is always what's in front of x. So in this case, it's going to be negative a over b. That's always going to be the slope. So instead of doing all this work every single time, we can just look at the original equation and just say, if we just do negative the number in front of x, a, divided by b, that's going to be the slope. The y-intercept is the second part over here, c over b. That's where you would normally start to graph the equation. The number that's by itself, c over b. And the last part, what we don't have yet, is the x-intercept. And we did this, I think, in the first section of this chapter, where we were finding the x-intercept by finding or using y equals 0. So if we say that y is equal to 0, if y equals 0, then we have ax. So just pretend we're using this equation again. I'm just going to plug in 0 for y. Ax plus b, not y, times 0 equals c. So what happens here? B times 0. That just kind of goes away. That's just ax plus 0, which we don't have to write, equals c. And then we're just going to solve for x. Divide both sides by a. C over a is going to be the x-intercept. And why is it the x-intercept? Because we used 0 for the y value, which means we're at the x-axis. So this would be c over a. What I would recommend is just basically memorizing these three things. So if you need to find any of these, you can always go back to the original equation ax plus by equals c, and just use the numbers that are in here to find the slope, y-intercept, and x-intercept. So we're going to try an example where we use these shortcuts, and I'll reference back to them. Example 1, graph the equation below just using the x and y intercepts. So first thing you should do is we're going to label each of these numbers in order. If you look back here, ax, a goes with x, b goes with y, and c is the number by itself. So it's going to go a is -5, b is 2, and c is 10. This is a shortcut. So if you don't remember it, how do we get the x-intercept? Let's see. X-intercept is c over a. So I'm just going to label that as such. The x-intercept is c over a. Let's plug the numbers in. 10 divided by -5. So that is -2. So the x-intercept is where it crosses the x-axis. So we put -2 right here. All right, now time to do the y-intercept. What is the shortcut for the y-intercept? If you don't know, you can go back and look. Y-intercept is c over b. So what's the c value? 10 over b, which is 2. So that value will be 5. So this means we put a dot on the y-axis because it's the y-intercept at 5. Whoops. And just to practice it, I think right now we could probably just draw a line between the two. If we just connect the two dots, that will make the line for this graph. And that's all we would need. But I also want to practice doing the slope. If you remember what the slope was, go back again. -a over b. So we have to include a negative sign. Negative, what's a? A is a -5. So we have a double negative all over 2. So it looks like we're going to have 5 over 2. So if you want to get more dots, you could use the slope, and then you can count blocks. So if you look at going down here, you could go down 5 over 2. Oh, that's exactly what we have here. You could go down 5 over 2 and keep doing that. I'm just going to draw the line, I think. Or maybe I could put another dot on here. 10 over 2 would be here. Go up 5 over 2. And then down 5 over 2 would be -5 to -4. So you could do it this way as well. This specifically just said to use x and y intercepts, but I could use all three if I wanted to. And then you draw your line through there as best you can. And that's the graph. Example 2. Why can you not use the x and y intercepts, so the little shortcuts that we just did, to graph this equation when c is 0? So let's see what that looks like. ax plus by equals 0. So let's try doing it and see what happens. The x-intercept is, again, do you remember what it is? You have to go back and look. X-intercept is c over a. So our c value right now is 0. So it's 0 over a. Actually, it doesn't really matter what a is. 0 divided by any number is 0. As long as it's not on the bottom, we're good. The y-intercept, what's that one again? Maybe you know by now. Go back. C over b. And what is c? That is 0. And b doesn't matter what it is again because you get 0. So why would we not be able to graph it based off the x and y intercept if c was actually 0? What's the problem? We would put a dot at 0 on the x-axis. We would put a dot at 0 on the y-axis, and we would only have one dot. It would actually just be at the origin, right? If we would go on the x-axis, put a dot at 0, go to the y-axis, put a dot at 0, we'd have no graph. So it does not work when c is 0. All right, example 3. We're going to graph x plus 0y equals 3. I'm going to go ahead and do the same thing we did before, doing the x and y-intercept. And if you are confused with this at all and you want to try to identify the numbers, figure out what is in front of x here. When you don't see a number, that's going to be 1. So let's label our a, b, c. and then we can do our x and y intercept. So x-intercept is going to be c over a, which is 3 over 1. So it crosses at 3. Y-intercept is c over b, and that's going to be 3 over 0. Wait, so what's that? Can't have 0 in the denominator. Remember, this is one of those times where you get an error or undefined in the calculator. So you actually can't graph that. So what does that mean? What's the y-intercept? That means there isn't one. It's not going to cross the y-axis at all. So how do we draw this line then if it's never going to touch the y-axis? It has to be parallel with the y-axis if it's never going to touch. Even if it's slightly slanted either direction, it will eventually touch the y-axis. So this is actually a vertical line straight down at 3. Is this a graph of a line? Yes. Is it a graph of a function? If you remember good old VLT, it would absolutely fail being a function right here if you draw a straight line there because you hit all points. So no, we could say it fails, if you remember this, fails the good old VLT, which is a good enough example here. All right, last one. Find which equations below, if any, represent the same line. And we're going to check both the x and y intercepts to see which ones match. So normally we just go through and I would have different groups of people actually do each one to see if they match. But on here, we will just try them all. So hopefully you can do it quickly, figure out what the x and y intercepts are. What I would recommend is maybe trying them yourself first and then see if you get the same thing if you know them by now. You just have to kind of memorize them. The x-intercept is going to be c over, remember you can label these. It's going to be 12 over c over a, which is 4. So this is 3. Y-intercept is c over b, which is 12 over 1.5. So you can actually divide them. It ends up being 8. So really we're gonna go through here and see, do we get a y-intercept or x-intercept of 3 and a y-intercept of 8 for any of these other ones? All right, so A, B, C. If it does happen, then we know that they are the exact same line. That's really what we're checking for here. And it's a fairly quick check just by dividing some numbers. So this would be 24 over 8, which is 3. The y-intercept would be c over b, so 24 over 3, which is 8. Ah, we got one. So these two equations are the same. Now, if you look at them, you may not recognize that they're the same, but maybe you can see how they actually are the same line. What's the difference between the two? 4x plus 1.5y equals 12, and 8x plus 3y equals 24. Well, if you just actually double all of these numbers, or if you think about cutting all these numbers in half, you get the same equation. All right, let's try the last two. This x-intercept would be 12 over 8, which if you divide, you get 1.5. The y-intercept, again, I would just memorize these. This one is going to be 12 over 3, which is 4. So it doesn't match the other two, clearly. And the last one, if you need to label it, go ahead, A, B, C. I didn't do that to the last one. We'll see if this matches the other two. The x-intercept is 12 divided by 16, which is 0.75, I believe. Actually, by looking at it right now, you should be able to say it's not going to match any of them because none of them x-intercepts came out to be 0.75. But I'll do the last one. The y-intercept would be 12 over 6, which is 2. So 1 and 2, I guess, were the only ones that matched and were the same line. The other ones are all different lines. So So I guess the biggest takeaway from this section is you need to know and memorize these three things: slope, y-intercept, and x-intercept. And then being able to use that and apply it to make a graph is pretty much all we're doing. I think the rest of it should be fine to do and finish yourself. And so that'll be all for 3.3, and I think we'll be ready to take a quiz soon.